have any specific questions, but I'm here to go over whatever we think needs to be gone over.
All right. Robert, you just want to start at number 2 on that homework?
Sure.
Okay.
Unless you have an easier way of explaining 7.5.
I think just doing some of the examples is the best way, and I don't really know if there's like a easy way to do them. I think unfortunately they just take a while, but we'll see.
Oh yeah, sorry I haven't been to even though they're not mandatory, still apologize that I haven't been to the other meetings.
Yeah, don't worry about it.
I've been filling out apartment paperwork for Charlotte.
Oh, I bet that's hard to do right now, considering everything is closed.
It's all digital.
Oh, okay.
So.
Well, that's not too bad then. Are you staying on campus or your own place?
They do not allow married couples to live together on campus.
Right. Yeah, I figure.
So.
All right.
Kind of dumb.
Yeah.
Unless I wanted to pay $1,200 or more a month.
Jeez. No, you don't want to do
That's
that.
a lot.
All right, let's do this one. So this is just number 2 here. Or is this the one that I did last time? Or did I do number 1? I must have done number 1.
I wasn't there.
I must have done it because there's something filled in here. So we'll do number 2. Okay.
Number 1 took me like 4 tries.
I think when I did it the first time, I had messed up too. So we're going to go this real slow so we don't make any mistakes.
That sounds like a reasonable plan.
Yeah.
And I'll try to follow along with my numbers.
Okay, cool.
And did you start recording yet?
I think I did. Let me just double check though, just in case. Yes.
The red dot's not there.
Okay.
It's not there, but it says it's recording. Recorder is recording. I think we're good.
Okay. Cool.
Okay, so first things first, you could solve this question using the chapter 4 stuff, but that's not really the point, right? Even if you did do the chapter 4 stuff, it would still take you an hour to do it. Hopefully the Laplace method would actually make it a little bit quicker, and it's definitely quicker for the more complicated ones. I think these first few on the homeworks are just to kind of get you used to using the Laplace method before you get into the ones where you have to use the Laplace method.
Gotcha.
All right, so what we're going to do is we're going to take the Laplace of both sides. So the Laplace of the second derivative plus the Laplace of 3 times the first derivative plus the Laplace of 2 times the function y, that's equal to the Laplace times 168 e to the 5t. Okay. I just realized that I should have pulled the book up here because I'm going to need that table in the book that gives me the
I
Laplace.
think you can just click that link and it'll pull it up.
Oh, that's right. There's a button that does. Okay, never mind. We're good. You're right. On the homeworks, it lets you do that. Okay.
Yeah, I printed them off.
Oh, good. That's smart. All right, so looking at this, we're going to have to break this all down to get rid of the derivatives and to try to get rid of as much of the Laplace operators as we can, including taking the Laplace of this function on the right-hand side. So just looking at the table of properties that they give you here in the homework, they should have the derivative properties here. So this line is the first derivative property, and then the line right below it is the second derivative property. So this is scratch paper now. What I would do is go ahead and figure out what the Laplace of the second derivative is based on the initial conditions that they give you. So just looking at the formula over here, the second derivative of a function inside the Laplace operator is s squared. So remember, that's the new independent variable. The Laplace of just the function itself, I should be doing curly brackets here. I guess it doesn't matter too much. So I know there's like a lot of fluff in the formulas here, and it is all important, but just know that the curly brackets is the function you're taking the Laplace operator for. This parentheses of s is just telling you that when you do this, your function is going to be a function in terms of the new independent variable s. So it's not like there's an extra s there. That's just telling you that the Laplace operator changes this to be a function of s instead of a function of t, like it was to begin with. Okay, anyway, so we have the s squared s squared times the Laplace of y. That's going to be minus s, And then our function, which is the y at 0, minus the derivative y at 0. So plugging in what we have, the s squared is going to stay, the Laplace of y is going to stay, minus s times, the function at 0 is coming from the initial condition here, so that's -8, minus the derivative at 0, also coming from the initial condition here, that's 38. So what we end up with is that the Laplace operator of the second derivative is s squared, the Laplace of y, plus 8s, and then minus 38. Okay, so we'll plug that back in up top here when we're ready. We still have to find the Laplace of the derivative y prime. That, again, coming from the formula over here, is s, the Laplace at y, minus just the function y at 0. So for us, it's going to be s times the Laplace of y, and then plus 8 when we plug in -8 for y0. Okay. I would also go ahead and figure out what the Laplace of the function on the right-hand side is. So this Laplace of 168e to the 5t. We're going to need that other table here from the homeworks to do that one. All right, so this function is matching this, just e to the at. Remember that there's a coefficient. You can just pull that coefficient out or kind of like bring it along. So that 168 is just coming along. And then the Laplace of e to the 5t is going to be 1 over s minus 5. So we can just leave that as 168 divided by s minus 5. That will plug in on the right-hand side of our equation. All right, now that we have these things, we're going to substitute these all back into the differential equation that we have after we took the Laplace of all of the terms. So we're going to have the Laplace of the second derivative, which is the s squared, Laplace of y, plus the 8s minus 38. Plus, then we're going to have 3 times the Laplace of the derivative, which was here. That was just s, the Laplace of y, plus 8. And then we're going to have plus 2 times just the Laplace of y. That's going to equal that 168 s minus 5 on the right-hand side. All right, now we want to simplify it down and solve for that Laplace of y. So we're going to combine all the like terms together. For all of the Laplace of y's, we have an s squared, we have a plus 3s, and we have a plus 2. So that's just combining all of those coefficients together. We have a bunch of other stuff floating around too. Looks like we have a plus 8s. 3 times 8 is 24, so then a minus 14. Just double checking in my head here. Yeah, that looks good. Okay, still solving for the Laplace of y. We're going to move these other two terms to the right-hand side. So we still have that 168 term. We still have the s minus 5 term, but now we've subtracted the 8s over and we've added the 14 over. Eventually we're going to divide by this, so it would be nice if all of this on the right-hand side was just a single term. So we're going to have to do some like fraction here and combine all of these together. So this is just working on the right-hand side. I'm going to leave that first term alone. But then these other two terms are going to multiply top and bottom by s minus 5. I think I'm even going to get kind of clever with it and do it like this. Just do it as like one big fraction over s minus 5. Oh, I forgot to multiply the top by s minus 5 though. Don't forget to do that. Okay, so foiling all that stuff out. I hope I did that right.
Yeah.
Okay, and then now we can combine the two fractions together. So we have just s minus 5 on the bottom, but up top we have negative 8s squared plus 54s, and then plus 98. All right. This numerator...
That's 98.
Plus 98, yeah?
Mm-hmm.
Okay. This numerator may be factorable. So that's something you would want to check. So does all of that divide out by 8? I can't really tell. Does 8 go into 98? No, it doesn't.
No, it doesn't.
I guess we could factor everything by only by 2. So I could rewrite the top as negative 2 times 4s squared minus 27s minus 49 over s minus 5. Now, can that be factored? Yeah, it looks like it can. So let's see. So if I factor one of these into s minus 7 and then the other one into 4s plus 7, so that's negative 28. Oh no, but that's plus 7. Oh, that's not going to work. Maybe it can't be factored. Let's cheat. Google. Factor.
Go to
What was it? Negative 8s squared.
Plus 54s plus 98.
I got easy. Mine was way easier. It's 4 and 36.
Aw, I wish mine was easy.
Hey, you're welcome to do mine.
Yeah.
Simplify negative 8x squared plus 54x plus 98. Oh, it doesn't look like ours simplifies.
Yeah, it looks like that's as far as it goes.
Bummer. Okay.
Mine did.
Well,
Mine factored.
yours might be good then. Okay. So let's just keep going and hope for the best. So that's our right-hand side now. So if yours factored, great, and hopefully something will cancel out. So now we're going to divide over that coefficient that was on the Laplace. So I'm still going to leave the numerator alone. Negative 2, 4s squared, minus 27s, minus 49. But then I'm going to divide that by... so we have the s minus 5, and when I divide this thing over as well, it will factor. Right, so when I divide it over, I'm just going to go ahead and factor it as I do it. That'll factor into s plus 1 and s plus 2. Okay, cool. Now, unfortunately, that is the solution for the Laplace operator, but we want to find the solution for just the function, which means that now we need to do the inverse Laplace of this awful looking thing. I think the easiest way to do it would be partial fractions. Partial fractions because my denominator is all factored out. And so I can hopefully break this down into 3 separate fractions that add back up to these, and then I can do the inverse Laplace of each of those. All right, here we go. So that is going to equal to a over s minus 5 plus b over s plus 1 plus c over s plus 2 All right, so now what I would do, right, is I would set these two things equal to each other and then multiply both sides by that common denominator. On the left-hand side, I'm going to multiply that 2 back into it because we kind of need it in there. These are going to get ugly. Okay, so multiplying it all out, it would end up being this. At this point, I would probably use technology to solve for the A, the B, and the C here. Although, I guess it wouldn't be too bad, because you can just try different S values. So we could try S to be -1. If I plug -1, it'll make a lot of these go away. On the left-hand side, if I plug -1 in for the S, I'm going to get a +8. A -54, and then that +98. On the right-hand side, this is going to go to 0. My last one is going to go to 0, and if I plug -1 into the middle one, I get the B, I get -6, and I get -1. Nope, +1. Okay, so I might need some calculator help here with just adding these numbers together.
So it's the 8 minus 54 plus 98.
Yeah.
That gives us 52.
All right, and then we're going to divide that by -6. It doesn't go into it evenly, does it?
No, it doesn't. That gives us -26/3 if you want to simplify.
All right. Oh, that worries me. It makes me think my numbers are weird. We'll keep going. After that, we're going to try...
Sometimes my labs likes to give you weird stuff.
It does, you're right. So next we're going to try -2 to make some more parentheses stuff go away. If I plug -2 in for the S's on the right-hand side, we're going to have 8 times 4 minus 54 times 2 is 108 plus the 98. On the right-hand side, the first two big terms are 0. We're going to get the C, the -7, and the -1.
So I was able to do like complete the square. Should I do that then?
Yeah, if yours came out to be completing the square instead of partial fractions, then do that. It's a lot easier.
But that leaves me where I'm stuck because then I got like S plus 63 and then S minus 4 all squared minus 31.
Okay. After we finish this, because we're almost done, tell me what you have and I'll show you how to do that.
Okay.
So 22/7, does that sound good there? Adding these together divided by 7?
Yes, it does.
Okay. And then the last one we want to try would be S to be +5. So 8 times 25 on the left, plus whatever 54 times 5 is, plus 98. That's going to be an awful number. On the right-hand side, we get the A times 6 times 7, it would be. Definitely need calculator help with this one.
So 8 times 25 is 200 plus 270. That gives us 568.
And if I divide that by 42, does that do anything for us?
That simplifies to 284/21.
Okay. All right.
So, not really.
No, not really. So combining all these together, we get our final thing, right? We have that 284/21. That was the coefficient on S minus 5. Plus, the B was -26/3. That was the coefficient on S plus 1. And then plus the 22/7. And that was the coefficient on S plus 2. Okay, each one of these is going to be an E. So if I go back to the homeworks, right, we're still using the same table, but we want to use it backwards. Every single one of these is going to match the second row here, 1 over S plus or minus a number, and it's the opposite of that number that's going to be the coefficient inside the exponent of e. So finally we get that our function y of t is hopefully 284 over 21, that's going to be e to the 5t, minus 26 thirds, that's going to be e to the negative t, plus 22 sevenths, and that's going to be e to the negative 2t. So that's it, and that should be the final answer. It looks funny to me. I hope it's right. Oh, I didn't go into my teacher thing, so we're going to have to type this in.
So there is a teacher mode.
There is.
Yeah. It has the like show all answers button.
Yeah.
Oh, that's fancy.
Oh, all right, so we goofed somewhere. One of my numbers is funny. I thought we did everything right. I don't remember I don't see where we could have made any small mistakes. It must have been somewhere in here where we were combining all this stuff together. Let's see what the right answer is. There we go. Oh, look how nice these numbers are.
Oh, yeah.
It happens to me every single time.
But notice that we do have the right functions, right? E to the negative 2t, e to the negative t, and then e to the 5t. All the right functions. It's just that somewhere along the line, one of our numbers must have messed up because our a, b, and c values came out to be so funny. So just a small mistake. Okay, so
Doesn't count on the test if it's just a small mistake.
well, that's why I ask you to submit your work. That way, if I do see a small mistake like that, I give you the majority of the credit back. Robert, what was yours so I can show you how to do the completing the square stuff?
Well, what I've gotten all the way up to was the s plus 63 divided by s minus 4 all squared minus 31.
Like that?
Yes.
A 31 here?
Yes.
Oh. Really? I think this 31 looks funny. The rest of it...
That's what the numbers gave me.
The rest of it looks good. So what you want to do is you want to force the top to be an s minus 4. So basically what you're going to do is you're just going to rewrite that numerator as s minus 4, and then whatever else you need to make it be the s plus 63. So we're going to have an s minus 4, and then we're going to have a plus 67. That way it simplifies back out to be what it was. There we go. You know, if you combine the negative 4 and the 67 together, you still get this. But the reason we do that is now we can break this up into two separate ones. We're going to have s minus 4 over that denominator. You want these to match up, the parenthesis bottom and then the numerator. And we're also going to have a 67 over that same denominator. Okay, and then if we go to the homeworks and we go back to that table of transforms, that's going to be the bottom two. So the first fraction that I have is the e to the at cosine bt. It might still work out, it's just going to be a square root of 31 here for the b. And then the second fraction is going to be the top one here. You'll have to factor the 67 out and then replace it with the square root of whatever the bottom number is. So your numbers look weird too.
I say it's my lab's fault.
Might be.
Yeah.
And the sad part is these take like forever, and then they only get worse.
Yeah, they do get harder.
I think getting harder is an underestimate.
Yeah.
Let's try a harder one then. Let's see if we can actually get one 100% right. So skipping 3. 4 would be fun. Let's try 4.
You have a very different definition of fun.
It's like doing a puzzle, right? Like it's challenging.
Yeah, kind of. If the puzzle is on fire.
At least one side of the equation is the same as mine.
That's good. Okay, so just writing it all out, and again, we're doing this using the Laplace transform stuff. So we're going to take the Laplace of the left-hand side individually, and we're going to take the Laplace of the right-hand side also individually. I'm factoring out the constants as I go. Be careful of that last one, because the Laplace of 1 is not just 1, like it's a function. So if you take that 68 out, you're still taking the Laplace of 1. All right, we're going to do the same thing that we did before. We're going over to scratch paper to figure out what all of these are individually before we substitute them back in. So the second derivative, and we'll pull up the properties table here. The second derivative is s squared, the Laplace of the function y, minus s times the function at 0, which is just 0, minus the derivative of the function at 0, which is 1. So that simplifies down to be s squared, the Laplace of y, minus 1. We'd also want to do the Laplace of the first derivative. That is just s, the Laplace of the function, minus the function at 0, which is 0. So this is just s. Oh, you know what? We didn't even have to do that. Sorry, I just looked at the equation. We don't even have a first derivative in there anywhere. All right, ignore that line.
Okay.
Sorry. Okay, moving on to the next term. Because 16, the Laplace of y is just going to stay that. And there's nothing to break down there. So now we're here. The 32. Oh, forget the 32. Just the Laplace of t squared. Now we have to go to the other table, the common Laplace transformations. T squared is going to be the third row here, t to the n. So if I just replace the n to be 2 on the right-hand side, I get 2 factorial, which is 2, divided by s to the 2 plus 1 power, so s cubed. So the Laplace of t squared is 2 over s cubed. We need the Laplace of t, so using that same 1, that's going to be 1 factorial divided by s squared. We also need to write down the Laplace of 1 because it's not trivial. That's the first row up top. The Laplace of 1 is 1 over s. Okay, now we're going back to the differential equation, and we're substituting in all these Laplace transforms. So we have the second derivative of y, which we wrote out here. That's s squared, the Laplace of y minus 1. That's plus 16 times just the Laplace of y. All right, that is going to be equal to the right-hand side. We have the 32 that we pulled out, and then t squared is 2 over s cubed, minus the 48, and then the Laplace of t is 1 over s squared, and then plus the 68 Laplace of 1, which is 1 over s. All right, and now we want to do the same thing here that we did before. It would really be helpful if this was just one fraction on the right-hand side. We are going to have to add this 1 over, so let's go ahead and simplify down a little bit more. On the left-hand side, we're going to get the s squared plus 16 times the Laplace of y, just looking at the coefficients. On the right-hand side, just bringing in all these coefficients here, we have 64 over s cubed, minus 48 over s squared, 68 over s, and then we're going to have a plus 1 that we moved over. We have to make all of these to be s cubes, so we can add them all together, leaving the first one alone, minus 48s over s cubed for the second one, plus 68s squared over s for the last one, or for the third one, and then plus that we're just going to have to leave as s cubed over s cubed for the 1. And now if we add these all together into one big fraction, Well, I'm going to put this in order. Like that. Last little step is going to be dividing over the s squared plus 16. So we're going to get the Laplace of y is big fraction. That top thing, which I'm hoping that can be factored. We'll try to factor it here in just a second. All divided by s cubed times s squared plus 16. Cool. So that is the Laplace transform of my function. I would just have to figure out the inverse Laplace transform to get my actual answer. Okay, great. Let's try factoring the numerator just to see if we can. It kind of looks like we can't, though. So whenever you're factoring these 4-term polynomials, pull a common factor out of the first, and then pull a common factor out of the second, and hope the parentheses match up. But it doesn't look like I can make that happen because of the 68 here. Oh, well, I think we're stuck with it.
Wonderful.
I think the only other thing that we can do now is divide each of these by this s cubed and write these back as single fractions. It looks like one fraction didn't help us. Let's just write it out and see what happens. Because that is one that we can do now. So s cubed divided by this, 1 over s squared plus 16, that looks like the sign of bt here. Plus, then we're going to have 68 times, it's going to be, man, I don't know how to rewrite this the best way. 1 divided by s times s squared plus 16. Okay, so that sucks, but it just is what it is. And then minus 48 times, this is going to be 1 over s squared times s squared plus 16. And then plus, finally, the 64 times it. So 1 over the s cubed. Okay, so this first term is just directly going to be the sign of bt, where the b is 4. We are going to have to force a 4 to be up top by factoring out a 1/4. So that we can do. This second term, because it has this extra 1 over s in front of it, I'm trying to think of what to do, and I think we have to go back to one of these other tables. I was trying to see if it was going to be one of these weird ones like this, where it's the derivative of a Laplace, kind of. Like you can think of that as the derivative of 1 over s squared plus 16, but it doesn't quite work out. I have to think harder. Unless I substituted a number in wrong and it didn't simplify down like I would have hoped it would have. Oh, okay. I got it now. All right. So unfortunately, we're going to have to rewrite this again. I was on the right track. I just shouldn't have done it for all 3 of them. I should have only done it for the first one and then left this other one kind of as is. So what I mean by that is we're going to leave the 1 over s squared plus 16 out in front. But then all of this other stuff we're just going to leave as that whole thing over this whole thing, and then we can do partial fractions from there. So plus the 68s squared minus 48s plus 64 over the s cubed s squared plus 16 thing. All right, and then from here, we're going to do partial fractions. Although the partial fractions are going to be kind of gross. So when I break this up, because I have the s cubed here, remember that we would have to have 1 over each of them. We'd have to have a constant over s cubed plus a constant over s squared plus a constant over just s. And then the s squared plus 16, we would have to have a linear term, a ds plus e, over that unfactorable s squared plus 16 quadratic. All right, multiplying everything on both sides, we're going to get the left-hand side there. And then on the right-hand side, we're going to have a times the s squared plus 16 plus the b times s times the s squared plus 16 plus the c times s squared plus 16 and then plus s cubed times that ds plus e. All right, so that was just multiplying both sides by the common denominator here on the left-hand side. And then we probably should multiply all this stuff out, so that way we're looking at those coefficients like we've done before. Word is struggling with all of these equations on my end. Okay, so yeah, that was just distributing those parentheses out. Now we're going to have s to the fourths floating around. I have 0 on the left, and it looks like I just have a c plus d on the right. I have s cubes floating around, 0 on the left, and then b plus e on the right. S squared's floating around, 68 on the left, a plus 16c on the right. S is floating around. Just a 16b on the right. Something with an s in it? It looks like it. And then finally, constants floating around. I have the 64 on the left, and then I have a 16a on the right. Okay, so then from these equations, they're not too hard to figure out what all of these are going to be. It looks like the numbers are going to be nice, which makes me think that we're actually going to do this correctly. So 64 divided by 16 gives us a is 4. For this one, the negative 48 divided by 16 gives me b is negative 3. For this line, if the a is 4 and we subtract it over, we get 64. And then dividing by 16 gives me c is 4. For this one, if b is negative 3, that means e has to be positive 3. And then for this one, if c is 4, d has to be negative 4. All right, whew. And then plugging all this back in to the partial fractions up top here. So we get a, which was 4, over s squared, or s cubed, sorry, minus 3 over s squared, plus 4 over s, plus, and then the negative 4s plus 3 over s squared plus 16. Oh, man. All right, this is gross. Sorry. I now see why you're complaining. So don't forget, going way back to the top, we did have this extra 1 over s squared plus 16. That was the first term. And then this was our partial fraction decomposition. So the 1 over s squared plus 16, plus we have a 4 over s cubed, minus a 3 over s squared, plus a 4 over s, plus, and then this thing here. the negative 4s plus 3 over the s squared plus 16. Most of these we can just go ahead and do. This one for sure we can do. We just have to do that trick with the 4. We'll do that in a second. This one is going to be one of the t to the n things. We'll figure that one out. A t to the n thing. This is just going to be a constant 1 thing, right? That 1 over s. This one we're going to have to break down the way we broke it down and split it into 2 separate fractions. So that way one of them is going to be a sine, the other one's going to be a cosine here. Okay, so let's do all that. If I am breaking down this last fraction, I have the negative 4s over s squared plus 16 and then the positive 3 over s squared plus 16. That 3, I'm going to go ahead and add over here to this 1, which gives me the 4 that I needed in the numerator. All right, we're just going to check to see how the other coefficients are going to do. I'm going to bring this other one out to the front as well. So the negative 4s over s squared plus 16, if I go over to my table here, I just need a single s up top. So I am going to be factoring out that 4. The negative 4. Okay. 4 over s cubed. That is going to match with the third line here, where my n is a 2. That way it gives me the s cubed on the bottom, which means that my numerator needs to be 2 factorial, which is only 2, and currently I have a 4 up top. So I have to force it to be a 2 by factoring a 2 out of that fraction. So it was 4 over s cubed, I pulled a 2 out, and now it's 2 over s cubed. For the next one, negative 3 over s squared, that's going to be the same row, but this time the s is just 1, which means the top has to be 1 factorial, which is just 1. So I'm going to pull out that 3, the negative 3. And then finally the same thing here, I'm going to pull out that 4 and leave that as just 1 over s, because that's going to go back to just the constant 1. All right, all of that was the Laplace transform, which means doing all of the inverses now. This first fraction is going to be an inverse, and it's going to change into sine of 4t, because my b is 4. Minus 4, this one is going to be cosine of 4t, plus 2 over s cubed is t squared, minus 3, 1 over s squared is just t, and then plus 4, and then 1 over s is just 1. Okay, that looks really nice. It has to be the right answer. Yay. Okay. So I'll kind of walk back through the steps here because I know I jumped all over the place a little bit trying to figure out which way to get the inverse settled. So I'll re-talk through it and kind of go through my mindset here. I'll let you guys catch up. So when it comes to you guys working through these questions, what I care about the most is that you know to take the Laplace transform of both sides of the differential equation, you break it down using the table of properties until you can solve for the Laplace transform on one side. So that's when we ended up down here. We just combined it all into a single fraction, which is usually the way to do it and the easiest way to find the inverse. That did not help us out the way we did it because it was so awful. Although, I bet if we just did partial fractions to begin with here, maybe it would have worked itself out. So you probably could have just done the partial fractions from here instead of what I did, breaking it down into the 1 over s squared plus 16 and then all this other stuff. but it still worked out either way. So then the awful step of the partial fractions, which there's a lot there. So of course, like one little mistake is going to mess it all up. But I am okay with you making a small little mistake in this. So if you do everything else right and you just make a small little mistake here, trying to simplify down the inverse into things that are reasonable, I am not going to really take off hardly anything when it comes to the test question. But once you are here, and once you do have the Laplace actually written down and somewhat simplified, this step to me is important. Being able to break it down into recognizable inverses. That way you can use the table here and undo it. Okay, so that one was gross, and it's long, and I know, and I'm sorry. Math is hard.
Life's unfair and then you die, right?
That's what my mom said. Yeah. We have time to do one more. I'll do another quick one here, and maybe just kind of set it up and break it down a little bit easier. But are the steps okay? Regardless of the fact that it's long and it's difficult, are there any questions about the process?
I don't think so. I mean, it's pretty straightforward. It's just the simplifying it that gets tricky.
Yeah. Okay, so let's try one more before we go. That one's kind of the same. How many donuts to get a free pass on the semester?
Yeah.
Probably a lot of donuts. All right, let's just try this next one here, and we'll do it kind of quick. So here we go. So I'm just going to write it all out, taking the Laplace of both sides right off the bat. I'll just leave the initial conditions over on this side. Okay, so we've done this enough. At this point, I'll bring up the properties here. But I hope we can just do this, the whole substitution in one kind of go. We have the second derivative. The second derivative, using the properties, breaks down into s squared, the Laplace of y, minus s times the function at 0, which is 0. So this is just going to disappear and just be s times 0. We'll erase it here in a minute. And then that minus the derivative at 0, which in this case is 58. All right, so that's just the second derivative, and that's going to be minus 36 times the Laplace of y. On the right-hand side, this is where we have to use the other table and figure out what the Laplace transform of these individual functions. So we have the 180, and then the Laplace of t is 1 over s squared. So that's from the third line here, when my n is just 1. Minus 36, and then the Laplace of e to the negative 6t is 1 over s plus 6. That's coming from the second row, where the a is a negative 6. All right, simplifying it down. On the left-hand side, we have s squared minus 36, the Laplace of y. On the right-hand side, we have the 180 over s squared. We have the negative 36 over s plus 6. I'm also going to go ahead and add that 58 constant over here as well. Now we need to divide everything by this s squared minus 36. To do that, I again think it would be easier if the right-hand side was just a single fraction. That way maybe something will cancel out. So to do that, right, we'd have to get some like fractions going on. So the s squared minus 36 Laplace of y is 180 times s plus 6 all over s squared. So that's multiplying top and bottom by the s plus 6. minus the 36s squared over s squared, s plus 6. That's multiplying top and bottom there by s squared, plus the 58. We're going to have to multiply both s squared and s plus 6 onto this one on top and bottom. Okay, now we can combine all the like terms together and hope for the best. I'm going to distribute stuff out as I go. So one big fraction, 180s plus 6 times 180 is a number.
1080.
1080. Okay, cool. Thanks. Minus the 36s squared plus the 58s cubed plus, and then 58 times 6, 348.
Yeah, it's 348.
All right, that's s squared. That's all divided by the s squared, and then times the s plus 6. Combining all these like terms in the numerator together, that all breaks down to b. We have a 58s cubed, a plus 312s squared, just double checking my math here. That looks right. Okay, and again, we would try to factor the numerator. So out of these first two, I don't know if 58 goes into 312. It kind of looks like it does. Does it?
You said you want to see if 58 goes into 312?
Yeah. No, I don't think it does.
No, it just reduces to 156 over 29.
All right, what's the common fraction between these two?
That's a very good question.
How about this? Does 180 go into 1080? Because if not, it's not going to matter. Or if it does, it's not going to matter. I'll pull my calculator out.
That does. That goes in 6 times.
Okay, so because that one does go into this one perfectly, and this one does not go into this one perfectly, we're not going to be able to factor anything there.
Okay.
We're just going to have to jump straight into partial fractions. Which, you can always just jump straight into that anyway. Simplifying it would make it look a little bit nicer before you did some awful partial fractions.
The smallest thing you can take, well, the largest thing you can take out is a 2.
Okay, yeah, so that's not going to help us at all. We're just going to have to do the partial fractions thing. So we're going to have a constant over the s squared, a constant over just s, and then a constant over the s plus 6. You know what? I'm just looking at it. Because we have s cubed on top and an s cubed on the bottom, I think we would have to do long division.
That's gross.
That is gross. Okay, let's not do that. Let's cheat again. Cheating. We're going to do that same trick that we did in the last problem. I'm going to put the 58s cubed divided by this, and then everything else divided by this. So that's going to give us just 58s up top, and then s plus 6 on the bottom for the first fraction, and then plus the other stuff.
Could you explain again how that happens?
Yeah, so just think of it like when you have 2 terms in the numerator, and then just a single term in the denominator, and you break it up into the 2 fractions.
Gotcha, okay.
So this, the 58s cubed, I'm considering to be my first term. And then you can think of this as all being in like one big parentheses as my second term.
Okay, gotcha.
And then the 58s cubed over this, 2 of the s's disappear, so we just have 58s up top over the s plus 6. This we can't do anything with.
Gotcha, okay.
But now we can do partial fractions of the second thing. The second thing would break down to be an a over s squared plus a b over s plus a c over s plus 6. Multiplying both sides, we're going to get the 312s squared on the left, the 180s plus the 1080. That's going to be equal to the a times s plus 6, the b times s plus 6, and then the c times just s squared. Well, we can simplify that down by distributing out those parentheses, and then again setting the coefficients equal. So then we're going to have some s squared terms floating around. These numbers do not look like they're going to come out to be nice, but that's okay. All right, so I know I did those partial fractions kind of quick, but there's the three equations that I would get. So to solve for the a, we would divide the 1080 divided by the 6, which is 180. So then here, if a is 180, and I subtract it over, that gives me b is equal to 0. That's kind of nice. I mean, not nice for b, but nice for us. And then that means that c has to be 312 since the b is 0. All right, so starting back up top here, remember that we broke down our Laplace as the 58, the s over the s plus 6, not 68, sorry, 58. And then we also have the partial fractions part of it, which is going to be plus 180, 1 over s squared. The b was 0, plus 312, 1 over s plus 6. So I'm going to go ahead and factor out those constants, because I know I need to factor them out anyway. Okay, cool. So now we're here. This actually turned out really nice for me as a teacher, because it's another teaching moment. Is everybody okay with where we are? Any questions so far? All right, I'm going to go with there's so many questions that we broke WebEx.
I guess my question is, when do you know, like, when to split that first term off, like we did?
Yeah, it comes down to how to do partial fractions, and you can only do partial fractions if the numerator's degree is smaller than the denominator's degree.
Okay.
But we had an s cubed up top and s cubed on the bottom, so we really should have done long division. But I tried to cheat it so we didn't have to do long division.
Okay.
But that leads to my teaching moment down here, because we end up with this, s over s plus 6, which does not match anything over here. So unfortunately, we're going to have to keep going, and we're going to have to break down s over s plus 6, and the only way to do that is with long division. Sort of. All right, so because s over s plus 6 does not match anything over here, but it's kind of close to the e to the at one, what I'm going to do to like really kind of cheat it even more, not cheat it is the wrong word, to use things that you may not think to use, I'm going to rewrite that numerator as s plus 6 minus 6. And then plus we have all this other stuff. I'm just going to leave all this other stuff alone. The reason I'm rewriting this first one like this is now I can break it up into two separate fractions that will match the stuff on the table over there. Because we're going to end up with 58 just as is, 1 minus 6 over s plus 6. Oops. And then all that other stuff that we had. All right, so now it will match some of the stuff over here. Okay, so then we just do it. All right, so the 6 over s plus 6, that would be the e to the at thing with e to the negative 6. The 1 over s squared, that would just be a t to the 1. And then the 1 over s plus 6 would be another e to the negative 6t kind of thing. So then just simplifying it all down. I know I'm running late, so I'm just going to give you guys the answer here. But you'll see we have the e to the negative 6t, and then we'll have the other stuff. So the negative 5, e to the negative 6t, another e to the positive 6t, that's coming from the other one. Where's the other one? Seacrest out. See, Rice. Oh, yeah, from up there. And then the negative 5t from the 1 over s squared part. I just had the wrong constant. I think there is a question. Oh, no, there's not a question help for this one. I could not find any questions that had the view an example and help me solve this for this section. Very few of them actually had it.
So does that mean we get to cut the amount of questions in half?
Well, you can, if you want.
That's going to hurt my grade.
Yeah, we need the grade.
Well, just try your best. You can do it.
Or at least extend it to like Thursday.
I could do that.
I think that would be reasonable.
I could extend this one because I know it's going to take you a while. That way, if you guys have more questions, we can do some more on Thursday too. I'll just put this one for next week, since the 6 and 7 stuff isn't too bad.
Okay.
But don't put it off, because like you've seen, it takes a while.
I'm going to be working on this tomorrow.
Okay.
Yeah.
Like I was working on it today,
Oops.
but I could only get through one question.
Well, I hope that this at least helps kind of showing you what to do. And I know that the worst part is just the algebra part of simplifying down the partial fractions part of it.
Yeah.
I mean, other than that, like as you're doing the questions, and I hold on. I clicked out of my thing. When you are simplifying stuff down, remember that your end goal is the stuff on the right-hand side of the table. Like this is what you're trying to simplify down the stuff to be in any of these forms. Although sometimes you may have to simplify stuff down to be in one of the property forms just to undo it. So
it's stuff that wasn't in your videos.
What's that? I did the partial fractions.
Well, you didn't do long division in your videos.
I know I
Or
didn't
that
show up.
sheet thing.
Yeah, I didn't show up in the videos. Or in the questions I did. But now I've done it. It's in this video.
Yeah. Alright. Well, I'll see you guys Thursday.
Yep, I'll be here Thursday. We'll do some more of these. Just some more practice.
Alrighty, sounds good.
Thanks for coming.
Yeah, bye.
Bye. See you, Thomas.